Hello everyone, my name is Amandeep Singh. I'm one of the lead technical marketing engineers within Cisco Security Business Group. In today's sessions, we will talk about streamlining compliance. We will see how you can achieve risk reduction and segmentation and microsegmentation objectives using Cisco's offering called Cisco Secure Workload. Let's jump right into it. So before we talk about Cisco Secure Workload and the capabilities that it offers to achieve your segmentation objectives and some best practices and approaches around it, let's quickly understand how today's application and enterprise application landscape looks like and what are the challenges associated with it, right? So today, every enterprise has its applications spread across multi and hybrid cloud environment. I'm not telling you anything unique. We all know that. And these applications are accessible from all sorts of entry points. There is no fixed entry point like it used to be with a traditional data center environment. Now with the cloud providers and all sort of connectivities between the on-prem and cloud, there are multiple entry and exit points from where applications can be accessed. So it makes really easy for the attackers to find one tiny loophole or one tiny entry point and then start spreading laterally from there on, eventually getting access to one of the crown jewel applications from where they can escalate their privileges, get access to more critical data, and eventually exfiltrate that data out to a command and control server. So this problem is becoming more and more common as the connectivity is sort of getting more and more complicated and more and more prevalent across these application components spread across different environments. What's the solution? Solution is very simple and very effective. That is segmentation, having proper segmentation in place. So that is what we will talk about. How do we go about segmenting these environments, and what are some of the key tools that you can leverage to achieve your segmentation goals and eventually meet the compliance requirements around that. So before we get to the approaches and how we operationalize those approaches, I want to give you a quick overview of Cisco's offering, that is Cisco Secure Workload. Just a 10,000-foot overview of what this solution and platform looks like and what it allows you to do. Just a quick summary, and then we'll jump into more details afterwards. So I know there's a lot going on this slide, but if you focus your attention to the bottom of the slide, you see the distributed data plane, right? What is distributed data plane? This is basically representing all your user to app and app to app communication landscape. So consider a simple example. You have a user is logging on to an endpoint device, could be a Windows desktop or a VDI instance, and then it goes over a network, bunch of network devices, could be load balancers, could be firewalls, could be routers, and then eventually it accesses the front end of the application. That's where it lands, the front end of the application. The front end of the application in turn talks to a bunch of backend components, the core logic, the databases, and whatnot, to retrieve the information that it intends to present to the user, right? Now, this application, starting from the front end to the backend core logic or API services to database nodes, all of this is either going to be sitting in a traditional data center environment, or this could be in the public cloud environment. It could be anywhere from that perspective, right? Now, also, these application components or workloads, as we popularly call them, are running on different form factors. it goes to be bare metals, then came the virtual machines, and now you have containerized form factors as well in the form of Kubernetes workloads. Now, given this landscape or this communication from user to application, and more specifically application to application, east-west communication, the first thing you want to do is get visibility into this communication. And let me define what I mean by visibility. When I say visibility, I mean first thing you want to know is what IP is talking to what other IP on what ports and protocols at what times, right? So in simple words, net flow information. That is the first piece of critical data that you want. Now, if I told you IP1 is talking to IP2 on port number TCP port number 80, that is useful information, but not quite, right? That is simply telling me some two IPs are talking to each other, but I don't know what those IPs are, right? At that point, another piece of peripheral data becomes very critical, which will give me a little bit more context into those communication, and that contextual information can be ingested from all sorts of external sources. For example, this could be your service now, where application teams are maintaining the records about the workloads that they are developing. This could be tags and metadata coming from AWS, Azure, GCP, or tags and metadata stored in the vCenter. Likewise, other sources of information could be DNS, Kubernetes annotations. If there is a user logon information, then you can that would be available from ICE, Active Directory, then likewise secure client and threat intelligence sources as well. So you marry that IP flow information with a little bit of context, and it becomes a lot more useful. Let me explain that with an example, right? So we go back to the same example, IP1 talking to IP2 on TCP port 80. If I add some context here in the form of tags and annotation, that same information would look like HR user on IP1 is making a connection to finance application on IP2 on TCP port 80. Now, all of a sudden, that same flow record is much more meaningful to me, because I'm seeing an HR user is talking to a finance application. Maybe that is expected, maybe it is not, but at this point I have enough contextual information to pursue further the investigation. So that's the first layer of visibility that Secure Workload provides you, that is contextualized flow information. Now, visibility is great, but that is just one side of the coin. What do I do with that visibility, right? That's where with all this telemetry that this platform collects, that is Cisco Secure Workload, what you can do is you can discover segmentation policies. So it will help you baseline or build a blueprint of your segmentation policy based on the telemetry that it has collected, which is great. That is the step number 3, as you see in the slides, right? So there is an inbuilt tool in the platform that does the policy discovery for you, giving you a very detailed segmentation policy. So obviously, if I tell you here's a bunch of ports and protocols that you need to open between some application components, you would not be comfortable in simply going ahead and deploying that. So there's an intermediate step. What's that? You want some sort of simulation or some sort of testing that you would want to do on those policies to determine that they are doing what the outcome of enforcing that policy is expected, and there are no surprises. And that's step number 4, policy analysis. So you would want to analyze that flow, that policy against the live communications that are happening in the app environment, right? So that's the policy analysis. How do you analyze segmentation policies? So Secure Workload has an inbuilt tool that allows you to do policy analysis using all the telemetry that we are collecting, right? And lastly, once you've validated the policy, at that point you are ready to go ahead and deploy that policy. And this is where again the power of this platform comes into picture, where all you're doing is defining human intent. I want app A to talk to app B on port number XYZ. That's the intent you define. It's the policy engine that takes care of translating that intent into specific rules that are understood by the enforcement points. So if that rule is going to get programmed on a firewall, then it has a certain specific syntax. That conversion is done by the platform, and all the complexity around that translation is abstracted from the admin. So simply as an admin, you simply define an intent, and that intent is translated and pushed to the right enforcement point by the policy engine of Secure Workload. So that's in a nutshell what the platform does. Let's switch gears a bit and try and understand when it comes to segmentation or compliance related requirements that are pertaining to segmentation. Where exactly do I begin? Where to start, right? If I am responsible for the security of a big enterprise, where do I even begin to deploy my segmentation policies, right? So there are two broad approaches that one can take. One is a bottom-up approach and the other one is top-down approach. Let's understand them one by one. So a bottom-up approach is where your segmentation objective is more focused on a certain set of applications. You have a small set of applications or crown jewels that you are intending to protect, and your segmentation is directed towards those specific set of applications. So at that point, you simply pick one application at a time and you define the policy, the segmentation and micro-segmentation policy surrounding that one specific application or group of workloads. And then at that point, you enforce that policy on one particular application and then move on to the next application. So this works well for a small set of application. The challenge there though is, since the segmentation policy is under the purview of a NetSec team who has to collaborate or interact with an application team who actually owns that application, sometimes if the right organizational frameworks or structures are not in place in an enterprise, this may be very time-taking process and may not be as quick as one would want it to be, right? Because of the different priorities among different teams. So when you move from app to app, you very quickly run into those sort of people process problems, and it becomes difficult to achieve the security objectives that you have set out to achieve. So that's the limitation with bottom-up approach. So what's the alternative? The other approach is top-down, wherein you start from top-down. So let's assume you are an Acme enterprise organization, a fictitious organization which has a data center, which has a production, development, and shared services zone, and you have a bunch of applications running in each of these zones. So what you do is you start top-down. What do I mean by that? So when you start, you define a certain set of guardrails, a certain set of policies intended towards reducing risk. I'll give you example of those policies in a bit, but the idea is to define higher level org wide policies, and those policies can be defined very quickly without much help or much dependency on individual application teams. These are known bad behaviors that you are enforcing across your entire organization to reduce risk. And once you have that initial set of policies or guardrails in place, those are basically inherited um, or trickled down to every single application that is out there in the enterprise. So it gives you a very quick time to value when you're starting in such a manner from top down. Once you have that initial guardrails in place, at that point you further move down, you select a set of crown jewel applications, and you start working your way down from there on. So the idea is to realize value sooner and not get stalled by inter-team collaboration obstacles and whatnot, but start from an enterprise level security strategy, right? So let me show you what examples of those top-down approach would look like. So in phase one, you're basically defining org-wide guardrails. What are these guardrails? Let's look at some examples. So these could be within my data center, I don't want any communications on certain set of risky ports. These risky ports are nothing but well-known ports where some malicious activity has been seen out there in the wild. These could be ransomware ports or some ports, non-standard ports, which are generally not used by any application to for any sort of communication. Another example would be if you have financial applications, then PCI out of scope application should not be talking to PCI cardholder data environment. So that sort of guardrail can be defined right at the top. And another example is production environment should not be talking to any pre-production environment. The IT network should not be talking to any OT network. So those are sort of examples of high level infosec guardrails that you can define right at the top, and then entire enterprise has to adhere to those high level policies and sort of reducing the risk right at the get-go. The next phase is ring fencing the application. So each enterprise application is ring fenced. What is meaning of ring fence? So ring fence is basically defining policies in three broad sections. So first section is outside or external to app communication. So what sort of communications are required from outside to a given set of workloads or applications. So an example would be RDP hosts are allowed to talk to these workloads, or Jumpbox is allowed to SSH to these workloads. So that's outside to app. And keep in mind, app is a group of workload. It's not like one server or anything. It could be, it would very well be, but that's the idea. It is basically a group or bucket of one or more servers or workloads. Likewise, the second area would be what is that app or group of workloads allowed to talk to outside their own scope. So DNS servers, DHCP servers, AD, certificate authority, and whatnot. So that's my second section of policies, app to external. And lastly, within the bucket or within the scope of that individual application, all the workloads are allowed to talk to each other freely. You could lock it down to specific set of ports. If you don't want to, that's fine. You can allow free flow communication between those group of application workloads, and that is acceptable because you have already reduced the risk by many fold by getting it to this level of segmentation. So this is called popularly known as ring fencing the application. So you're simply defining what is allowed to talk to my application, what is my application allowed to talk to the outside world, and everything within the application, I'm not messing with that. So that's my second phase. Last phase is a full North Star zero trust architecture, where every component of my application is further broken down and locked down as far as access, east-west access is concerned. So if I go back, this is basically a double click of this last policy, that is app to app policy. So you're further breaking it down, wherein you say internet is allowed to talk to my web tier is allowed to talk to my app tier, and app is allowed to talk to database tier on certain specific TCP ports. So you're really breaking it down to individual app components, and this is basically the nirvana stage or zero trust architecture. Now this may not be a segmentation goal for every organization out there, and that's absolutely okay. It totally depends on what sort of segmentation journey or compliance journey you are on, and you may not have, or this may not be practical for you in certain situations, and that's okay, even if you get it to the phase 2 stage. Perfect. Now, so we talked about approach, right? So top down and bottom up approach. And now let's pivot a little bit, and let's see how do we operationalize this this approach, right? How do we make it practical? How do we implement it in a real world environment? So I divide this whole operationalization aspect into 3 sections. The number one aspect is building the right foundation, right? So even before you think of segmentation policy, you have to get visibility of everything. You have to see everything to basically do something about it, right? And when I say see everything, what do I mean? 2 important pieces of information. Number one, asset inventory. You need to know what are all the applications that you're trying to secure, how are they changing over time. So real-time workload and asset inventory, right? The second aspect is how are these application components talking to each other. So a visibility into that, right? So the very first thing is getting the right tools in place to get that initial foundational visibility. How do you do that with secure workload? So there are 2 broad sets of approaches. One is an agent-based approach, another one is a network-based approach. With an agent-based approach, you basically deploy a secure workload agent on say your virtual machine, bare metal, cloud instance, or Kubernetes nodes, and that agent gives you the asset inventory as well as the flow visibility into what is happening in your environment. The other approach is the agentless approach. So network devices like Cisco Secure Firewalls, F5 or Citrix load balancers, or any switches for that matter that support standard IPFix or NetFlow flows. In case of public cloud, you can integrate over APIs to pull VPC or VNet flow logs, and likewise we have integrations with endpoint devices as well. So the idea is using agent or agentless approaches or agentless mechanisms to pull asset and flow information and have that foundational visibility and asset inventory. So once you have that, what are you going to do about it? You will basically try to organize it in a nice hierarchical structure. That is step number 2, apply order to chaos. So let's take an example here. So I am owner of I'm responsible for securing Acme organization, Acme organization has a bunch of application workloads that are under its own ownership, and then there are a bunch of entities out there in internet which we don't care about, right? That is the first layer of classification, something that I own and something that I don't own. That classification is basically done using labels. So anything, any workload that is tagged as uh, organization equals Acme is classified as internal, and anything that doesn't have that label, any IP, doesn't belong to me. I don't care about that, right? Now, next level of classification is within all the application workloads or servers that belong to me, uh, where are these application assets located, right? So some of these are going to be in the data center, others in cloud, and others in various other places that as an Acme org own or have. And this is where I use another label called location. So anything that has a tag called location equals data center will be classified or grouped under data center scope. We call it scope, right? And then we go to the next level wherein within data center scope, I have zones or environments. So I use another label key, environment equals XYZ, production, pre-production, or common services. And within those zones, I have different applications. So that is my last layer of my scope or tree structure, where I say application equals the name of the application. I use that label to classify different workloads sitting in pre-production or production environment into different application groups, right? So I've basically defined this hierarchical structure starting from top all the way to the individual application components. Now you would ask me, do I have to follow this very specific structure that I'm showing here on the slide? The answer is no. This is just a reference structure that Secure Workload as a product has a nice workflow, automated workflow that walks you through building this sort of structure. This is what we recommend, but it is not cast in stone. If there are segmentation objectives that are not that needs a certain specific modification to this structure, that is absolutely okay, and option is available for organizations to build their own sort of scope hierarchy in this manner, right? So now we've built this hierarchical structure, a sort of very nice hierarchical classification of our application workloads. At this point, we have laid down the foundation. Let me give you a couple of more examples just to help you understand this idea of organizing your application in this sort of hierarchical manner. So public cloud, right? Now, if you are familiar with any of the public cloud, you may have noticed that they already have this sort of hierarchy available or done inherently in the public cloud. So I will take example of, let's say, AWS, right? So Acme has internal applications. In these internal applications, some are located in cloud, and under cloud you have AWS. Under AWS you're going to have regions. Under each region you have VPCs, and in each of these VPCs you have applications, right? You see that structure is there already in AWS. In Azure you may have subscriptions, tenant subscription, and under subscriptions you will have resource groups, VNets, and whatnot. So that structure is available in that sense in Azure. Likewise in GCP you may have folders, projects, accounts, and whatnot. So that hierarchy already is inherently built into the public cloud. So good thing is Secure Workload has integrations with public cloud, so you can bring that hierarchy as is, and then we'll talk about what you do with it, right? So and likewise in the Kubernetes environment you would have similar, let's say, AWS managed Kubernetes clusters. In each Kubernetes cluster you're going to have multiple namespaces. Each namespace, let's say, hosts an application. So there's a very well defined structure there as well, is as far as that scoping or building hierarchy is concerned, right? Perfect. So we talked about building the foundation. So we got visibility into everything. We organized it into a nice hierarchical scope structure. Next step is streamlining the segmentation policy. This is where we start talking about defining the policy, the segmentation policy. So the first step itself is, how do I define the policy? I have classified, I have grouped my applications and workloads, but I don't know how they are talking to each other. I don't know how and on what ports and protocols these different groups of workloads or scopes are interacting with each other. That's where Secure Workload has a tool called it's popularly known as application dependency mapping, or policy discovery, simply called. And what this tool does is it looks at the scope structure, it looks at all the telemetry that we collected in terms of flow information, the asset information, the context, and it, based on that, it runs an AI ML based machine learning based model, and it builds the blueprint policy for you. It will build a policy for you. It gives you a nice visualization of that policy, as you can see on the slide here. And that policy is basically the segmentation policy that is available for you to further analyze, test, and enforce. So step one is building the policy. So Secure Workload has a policy discovery tool that allows you to build the policy. Now that you have the policy as a network admin, my obvious next step is, okay, I have this draft segmentation policy. I can't simply go ahead and enforce this or deploy this policy because I don't know what will be the consequences of that. And I don't want to break my network. I don't want to cause any production harm. That's the biggest concern, right? So the next logical step is, how do I validate that discovered set of policies and segmentation policy? How do I analyze it? How do I make sure? How do I get some more confidence into this discovered set of policy? And that's where we have the next tool in the platform, which is called policy analysis. So there's an extensive versioning. So if I'm modifying the policy, every single modification creates a new version of the policy, and that policy version, you can choose which version you want to analyze. So in this case, you can see in this example, I'm analyzing version 58. And when I say analyze, what I've been really doing is I'm taking this policy and I'm comparing it against the live flows and communications that I'm receiving from my data center or public cloud environment, right? So you can see a trend here at the center over time, how many flows are getting permitted, how many of those are getting rejected, and how many are were expected to be rejected, but they are actually escaping, right? And at the bottom, you can actually see every individual flow that is getting captured and what is the verdict on it. Now, keep in mind, the policy hasn't been enforced yet. This is simply a simulation, simply a sandbox test, wherein you are getting all the analysis and you're able to run some tests to see how the policy would behave if I were to deploy it. On the right hand side, I can also see the top ports, where the communications are happening, and you can filter it out on a bunch of different attributes. I'm just showing ports here as an example to see what are my top consumer and provider ports, or source or destination ports. So once I've done this analysis and I've gained some confidence into what my policy is going to do to my live traffic or my production environment, idea is to basically get to a state where there are no rejects, there are no escapes, and if there are rejects, then those are the rejects that I expect to happen in my environment. This is where your NetSec team is also doing a bit of collaboration with your app teams to get a buy-in from them, to basically say this is the expected outcome once the policy is going to get enforced. So once I have analyzed, I am ready to let me move forward. Yeah, I'm ready to enforce that policy, right? I've basically defined an intent. I'm going to go ahead and hit that enforce button, at which point secure workload platform will basically proceed to enforce or deploy that policy to enforcement points. And there are a range of enforcement points that are supported today. So in the world of agent-based approach, these policies will be programmed to Windows and Linux and AIX, and all different types of hosts. In case of Windows Linux specifically, Windows has the native firewall called Windows Filtering Platform, where the policies are programmed. It's a very lightweight, very low on CPU firewall that is provided by the Windows operating system. Agent simply manages it. So agent simply programs these policies onto directly the Windows native firewall, that is WFP. In case of Linux, it's going to be IP tables. This works for both IPv4 and IPv6, and this also leverages IP sets to achieve a larger scale in case there are a large number of IPs and rules that needs to be put on the Linux host. It leverages IP set utility for that. Then if this was a Kubernetes cluster, the enforcement point, secure workload has a containerized agent, which is deployed in the form of a daemon set. This is supported on all the leading container runtimes, so Docker, Containerd, CRI-O, whatnot, and a range of node operating systems, which is ranging from Linux to Windows, and whole bunch of other distributions of operating systems. One of the important things to call out here is the secure workload network policy, when is enforced on Kubernetes nodes and containers, does not rely in any form or shape on the CNI or service mesh network policy. So CNI has its own network policy plugin. Likewise, service mesh also has some segmentation capabilities. Those are independent of secure workload. Secure workload doesn't rely on those. Secure workload natively programs the IP tables to control the traffic inbound and outbound from the node, as well as the individual pods. Then there is the network-based enforcement point, which is Cisco Secure Firewall. So Secure Workload has very deep native integration with Cisco Secure Firewall, where it's capable of ingesting the net flow information from the secure firewall. Use that net flow information to discover policies, analyze policies, just like it would do with an agent, and eventually enforce that policy to a secure firewall management center, which pushes it down to the firewalls over APIs. So there is a comprehensive integration which allows us to push the segmentation policy to firewalls, that is Cisco Secure Firewall as well. There's an integration available with load balancers, native integrations with F5 and Citrix, which essentially does the same thing that I explained with Secure Firewall. Ingest flows, use those flows, ingest flows from the load balancer, use it to discover policies, analyze policies, and then eventually deploy that policy back to the load balancer. Secure Workload is intelligent enough to recognize different legs of communication, so client to web VIP IP, and then the backend source narrated IP, all the way to the application. It is capable of looking at those two legs of communications and provide you visibility, which is basically stitching those two flows and as well as when enforcing the policies, making sure those two legs of traffic are taken into account and policies are programmed accordingly. And for anything in the public cloud environment, there's native integrations with AWS, Azure, GCP, wherein secure workload can ingest the flow information from these three clouds to basically do is same thing that it does with agents and network enforcement points, that is discover policies, analyze them, and eventually enforce them using cloud built-in policy or firewalling capabilities like AWS security groups, Azure network security groups, and GCP network firewall. Lastly, anything beyond that, so you may have network switches, some other load balancers, or any other type of devices that are capable of exporting net flow information in the form of standard net flow records. So secure workload has a generic net flow connector that can ingest those flows and do the policy discovery and eventually enforce those policies by way of third-party policy orchestrators, to name them specifically Skybox, AlgoSec, Tufin. And so eventually these policies can go onto third-party firewalls or any other supported enforcement point by these policy orchestrators. Perfect. So we discovered policy, we analyzed it, and we enforce it to different enforcement points. It doesn't end there, right? So the last stage is continue monitoring. So once you've enforced the policy, you are going to continue monitoring the policy compliance. So secure workload continues to do the flow compliance analysis post the policy enforcement. So once you've enforced the policies, the same level of visibility is maintained. So for every flow or every communication that is happening on your data center or public cloud application environment, secure workload will continue to log whether it is allowed, rejected, and by what policy. It gives you a nice trend of permitted, accepted, permitted, rejected, or escaped flows over time. So if there are any anomalies over larger time, you can look for trends and whatnot. There are also alerts that you can configure to monitor for any escaped flows or any out of band policy changes that are happening on the enforcement points. There are also segmentation compliance and attack surface scores that are available in the platform for you to monitor, to look for how your security posture or segmentation posture over time is getting better or worse, and if there is anything that you need to take care of in that sense. So just to give you another interesting data points that you can monitor for to gain more insight once the policy is enforced is the trends around policy hit counts. Hit counts not just in terms of how many packets are matching a specific policy, but also how many bytes are matching, being transferred in the forward and reverse direction as far as each policy is concerned. So you get a nice trend on whether that is increasing over time, decreasing over time, and you can choose what time you want to see, what time interval you want to see those trends over. There's also something we call policy conditions. So for each policy, we have an AI engine that is running in the backend that analyzes these policies and gives you a little bit more insights or information about each policy. Some of the examples are, if there is no traffic matching or hitting a specific policy, the AI engine will continue analyzing that in the backend, and over time will notify you that you have a policy which hasn't had any hit for last 30 days. May be normal, may not be normal, but you may want to look at it and clean your policy or update your policy over time. So it's a problem. We have seen that over time these policies just keep growing bigger and bigger, and at some point becomes extremely unmanageable. So how do we maintain that policy hygiene? This sort of insight comes in very handy in those situations. Likewise, it will tell you if you have overshadowed policies. Again, as and when you keep adding policies over time, the whole policy groups gets very cluttered. So you get notifications or insights on the UI wherein if there is a policy that is overshadowed by another policy with higher priority, at which point this particular policy is redundant and needs to be removed, you will get a notification around that. And lastly, another example is the percentage utilization. So if you have a source and a destination, let's assume you have 100 IPs in the source, 100 IPs in the destination, but only one IP in source and one IP in the destination object are talking to each other. The rest of them never talk to each other. At that point, you have configured a policy which is too broad in nature. There's only like 1% or 10% utilization. You may want to fine tune that policy, segmentation policy, right? So sometimes you end up simply allowing things that are not supposed to talk to each other. So this kind of insight would help you with that. Now, all these insights sometimes can get noisy. So you do have control knobs on choosing what sort of insight you find useful and what sort of insight you don't want to see in your admin portal, right? So that's compliance, right? So basically ensuring that over time you maintain the policy, segmentation policy hygiene, and you update and track how your policy is faring or doing over time. So in summary, when it comes to policy, it's not something that you do once and forget about. It has a life cycle. It needs to be continuously looked at. So it's a virtuous cycle. So step one, you discover, define policy. Step two, you analyze, test, and simulate. You enforce to different enforcement points, and eventually you monitor compliance. And over time, you repeat that circle over and over again. So it's not something you just do and forget about. It is a process that needs to be done over and over and continuously. With that, this concludes my this session for the day for today. Thank you so much for your time. I hope you found the content useful. I'll see you on the next one. Thank you.